That's mine's up like oh, my bad. Oh, yeah, it is. I get all the extra credit. Even with that, I think that. Thank you. Someone, I don't know. I got it.
Okay, go ahead and read the problem, page 34. I sealed the graph for us and see how much you can figure out. And I'll definitely walk through each step with you. Okay, so make sure that we are getting off on the right foot here. The platform to get on the ride is on the top of the first hill. Top of the first hill is 18 meters high. That's where the ride starts at t equals 0, right? Ride starts at t equals 0. So make sure that's where we begin. And from there, see how much you can do. We're covering this. You're okay with this? Okay, so it takes 3 seconds to reach the bottom of the hill. Okay, so first off, it says write a cosine function, so that's nice. It's already kind of resembling that. How much of the period has been accomplished in 3 seconds? Half, yep, from peak to minimum. Right, if you think about a cosine graph, peak to minimum is half, and then from minimum that back up to peak, that's the full period. Okay, so we can kind of have an idea how to finish off our cycle here. Remember the midline or your p-value. The formula there, if you're given the peak and the minimum, you can add, find the average, right? I'm sorry. So 3 seconds to reach half the period, and then another 3 seconds to fulfill that full cycle. Max plus min divided by 2. So we know the halfway point is at 10. We can do a dotted line there. Now we know that everything is, our interval is all broken down into quarters, right? So max to midline to minimum to midline to max. So you know that your midline is going to occur halfway between your peak and your minimum. So 0 and 3, if I split that in half, that's 1.5, so 1.5. And then another 1.5 will give me to 4.5. Okay. What's our period? 6, yeah. So from your period, find your B value, find your A value by looking at your midline and your peak. No shift, so that makes it a little bit easier. We're going to have to do some shifts later on, but right now there's no shift. That's exactly what we expect cosine graph to look like. Okay, what's our A value? 8, yep. Peak minus the midline. 18 minus 10. Okay, you can name your function anything you want. You can say y of t, h of t, say h of t. This is a cosine graph that is not experiencing any inflection, so positive A. Okay. Any question with part A or B? Okay, part C, determine the height of the rider at 11 seconds. Just insert 11 for T. Use your calculator. Function notation just means say either y of 11 or h of 11 equals Make sure you're in radian mode. Yes. Well, the minimum is 2, but the peak is 18. So then I just found the average between 2 and 18. So I found that to be 10. Yeah. Okay, number 2 is a little messier because it's not lining up very nicely. But we can always kind of imagine what the graph could look like, and then we can worry about the shift later on to get it to look like that graph. Okay, so let me scale it here. I'll go up by 2s on the y-axis and go up by 1s on the x-axis. I'm sorry. Wait, I did go up by 2. Let me see what did I do. Yeah, I went up by 2s. Okay, so what about those points is helpful? Ultimately, this is the what of the graph. Minimum, and this is the maximum. Okay, so there's a lot of things we can gather here. From the minimum to the maximum, how much of the period has been accomplished? Half, yeah. So if you think about the reflected version of cosine, it's upside down. If I go from minimum to maximum, I've achieved half of the period, right? And then from maximum to minimum, I'll go back to getting that other half. So what's half the period? 4 seconds, right? 7 minus 3 is 4. So our full period is going to be 8. So add another 4, I'll get to 11. 11, I'm back down at 4. Okay, these are nice numbers here. If I take 4, divide it, split in half, I get 2. So I know that my midline is going to be right at 5, and then my midline is going to be also at 9. Okay, but let's find the midline first. Lowest plus highest divided by 2. So I have my d value right at 12. Okay, so I know that every 2 seconds I'll be able to get, so this is a reflected cosine, right? But we know that if I go over 2, I can hit all the major points that I want. Now we can find the A value, the B value, the D value, even without considering whether it's a sine or cosine function, right? So let's go ahead and find all the easy parts first. And then we'll talk about how do we get this sine function to show up, right? That's the hard part, figuring out the shift. But the A, the B, the D value, we can do all that. It's the same process for either sine or cosine, right? So let's get all the easy stuff out of the way. And then we'll talk about how we can get that sine. So period. Okay, what's the A value? Yeah. Yeah, from the midline to the peak, 20 minus 12 is 8. Okay. And our D value is, well, okay. So it says write a sine function. Okay. We got to make some adjustments here. But we know our A, our B, and our D value are good to go, right? Those we don't have to worry about. Those are stay the same regardless of whatever the shift is. Now, normally, the sine graph starts where? Starts at the midline, right? And what does it do? It goes up first, midline down and up. So maybe I can go a little bit backwards here. I know that my interval is 2, so I can kind of go back 2, and I can go to I'm sorry, 1. My bad, 1. And this kind of resembles a sine graph. That's been what? Been reflected. Okay. So I want us to draw this graph in. This is the graph we're trying to target. But this is not a sine graph without a shift, right? Because normally sine graph starts here, right? So I want us to do this, right? We know it's a reflected sine graph with the shift. So the reflected sine graph will make it what? Make it negative. Okay, so I want us to write the equation without the C value filled in. Okay, so let's do that. Or you say y of t. Okay. Is this equation the equation of vector? Not yet. Okay, not yet. Now, this is where I feel some students, last period, I realized that there was confusion about, wait, how do you know where to shift and all that? So let's do this. Let's draw in in a different color or in pencil. Let's figure out what does this graph look like? And let's get it on paper. If we can get this on paper, it's easier to figure out the shift because we can kind of, if we have an idea where this graph is, we can decide where it needs to go to turn to this graph, right? So this is a reflected sine graph, a reflected sine graph that starts at 0, right? And with a b value of a power of 4 and an interval of 2. So this is what, so every 2 units, I'm going to hit the next value. This is not the graph we want, but this is a very helpful tool. Okay, I'm going to put it in dotted line here. So Are we okay with, are we convinced that the dotted graph is the equation that we have right now? Yes, okay. So the question is this, but the dotted graph is not what we want, right? We want to figure out a way to get to the solid graph. And how can we move to the solid graph? To the right one. So therefore T what? Minus 1. Okay. I think what a lot of students want to do, they want to graph the, think of this as the sine graph and then figure out how to move it. And I feel like it's harder to wrap your head that way. So I would say, force yourself, if you're having trouble with this, force yourself to sketch an imaginary graph without the shift. And then you can figure out, how am I going to move that imaginary graph to the solid graph that I want? And based off of that movement from the imaginary to the real, that's going to be which direction you move, and that's going to be your C value. Okay, does that help? Does that make sense? Right. Okay, let's skip C for now. Okay, let's skip C for now, and we'll come back to it. Okay, let's go to number 3. Does anybody still need to look at number 2? Yeah, you can scale it any way you want. I'm going to go by 1s on the x-axis, and the y-axis I'll go up by 2s. Oh, sorry, my bad. Okay, back to what I did here. Misread it. Okay, 1 second, maximum height 14. Okay, peak to minimum. How much of the period have we accomplished? Half. So half the period is what? 9 minus 1, which is 8. So if the half period is 8, the full period is what? 16, right? So 8 and 8, 16. So 9 plus 8 will go to 17. So 17 is where the cycle ends. Our period is 16, which means our interval is 4. It just helps to just have those things lined up. Visualize this a bit better. We know that the midline is going to be 4 intervals away. Okay. We can also find the midline now. Average. Of the highest and lowest, 14 plus 2 is 16. 16 divided by 2 is 8. 14. Okay, is this where the cosine graph normally begins? No. Okay, so we know there's gonna be a shift. We'll figure out that shift later, but we'll save that for the end. Okay, find your A value, your B value, your D value, and create that cosine function. And then draw out what that imaginary cosine function is. That way you can see where you begin and where you end up and decide which direction you want to move. What's the A value? Now this looks like a pretty regular cosine graph, right? There's no reflection. It's just been moved. So starts at the peak, right? 6 cosine. That's 8. So let's stop, pause for a moment, sketch out what this graph looks like, right? This is obviously not the graph that we have in front of us, but if we can have an anchor to begin with, we'll have a better idea. Right, so 6 cosine, we know that we're going to start up at 14. Right, every 4 intervals, we're going to hit the next point that we need. So midline at 4, minimum at 8, midline at 12, max at 16. Okay, so this is what the cosine graph would look like without any shift. So the dotted graph is the equation that you have right there in front of you. So we got to ask ourselves, what can I do with the dotted graph to make it turn into the solid graph, which is what we want? Move it to the right 1, therefore what? -1. So I feel like if you go through this process, you're not going to get that shift incorrect. I see students, they get the shift incorrect because they feel like they have to move the solid graph to the cosine, to the dotted line, but that's not the case, right? We want the imaginary to turn into the solid graph, into the real graph. Okay, does that make sense? All right, so now part B, what is John's height from the bottom of the pool at 21 seconds? So just insert 21 in for T. At 8 meters. All right, last one here, number 4. I'm gonna scale by 1 for the x and then 4s along the y, but I saw some students, they scaled it by 6, and that works too, so you can scale it however way you want. Okay, just by those 2 points alone, it matches with which trig function? Cosine, right? And it's not being shifted, so that's nice. So we'll do the easier one first. It says write the cosine, so they're starting off easy. The sine requires a little bit of shifting, but okay. And then how much of the period have we accomplished? In 1 second, half, right? So in 2 seconds, we will have fulfilled our full period. Want to go for a couple more seconds. It could help later on when we're dealing with the sine, but you can find the midline, right? The A value, the B value, so all that's easy. No shift, so the cosine will be easy to create. But the sine is a bit more challenging. So if 1 second is half the period, then we know half a second is a quarter, right? So we can kind of easily figure out where these midlines will go. Again, I'm extending it a little bit just in preparation for the sine. Zero. No reflection. Okay, any question with part A? Okay. Everybody good? A is 12, B is pi, C is 0, D is 24. So the nice thing about sine graph is that we can carry all that information down, right? The same A value, the same B value, same D value. The only thing we have to worry about is potentially a reflection if there is one, or and what the C value is. Now,
we can go ahead and write that down because we want to create a sine function, but let me ask you this. Do you see? Okay, so we know what a sine graph looks like, right? Starts at the midline, goes up, midline, down, midline. Do you see a sine graph hiding in this one? And if you do, where does it start? Yes, okay, so there's two ways you can do it. You can start at 0.5 and then build a reflected version of sine, or you can start where? At 1.5 and build the original version. So it's really up to you. You can do it however way you want. I feel like it's easier to go after the graph that doesn't have the reflection. It just feels more familiar. So I'm going to highlight that because that is what we want to try to achieve. So that's our goal. Let's go ahead and write out everything that we have in place, right? We're targeting a sine function that does not have a reflection. So our A is the same. Our B is the same. We do need to save a spot for C. And the D is the same. So can we sketch what this graph looks like? Right. Obviously, this is not the graph that we have in front of us, or the one that is the one that's highlighted. But maybe we can create what this graph looks like, right? So midline is at 24. So using a different color ink or pencil, you know that every 0.5, you're going to reach the next interval. So that means at 0.5, it's going to reach its peak, midline, minimum, midline, right? So this is the graph. I'll use dotted line here. Really hard to see there, right? But the dotted graph is the equation that we have in place. But that's not what we want, right? We want to move it to the graph in highlighted orange. So how far do I have to move this graph that's imaginary and turn it into that dotted, solid, highlighted graph? Right, 1.5. So that's what we're going to do. How do I represent right 1.5? Minus 1.5. Okay, we take that original sine graph and we shift it in place of the one that we want. Okay, we still have to finish part D, but I'm going to save that for Monday. I do want to talk about what next week will look like to finish off this unit. Okay. So Monday, we're going to finish off the rest of the packet. So we'll do the next 2 pages. Okay. Now, down here, this is I haven't given you the new calendar yet, so I'm just writing this down at the bottom of the calendar. We'll give you a new calendar next week. So Monday, we're doing review. Okay. You guys just picked up a quiz review worksheet 2. That's what the quiz will look like. It'll be front and back. Okay. Tuesday is the quiz. It's going to be a partner quiz. Okay. Let me talk about how that's going to work. When you come into class on Tuesday, the desk will be organized in pairs. Okay. So you can choose your partner, or you can decide to work on your own. You don't have to have a partner. Now, this is what you can do with a partner. If you're working with a partner, you can collaborate, work together, talk to each other, but you'll be each working on different versions of the quiz. Okay, so you're responsible for your own version, but you can talk and collaborate, ask your partner, hey, does this look right to you? Or you want to check over my work? Okay, so you can collaborate, but you can only talk to your partner. You cannot talk to someone else who's not your partner. Okay, so I will try to organize it so that
everything is evenly spaced out. But if you just wanna just work on your own without having to work with someone else, you're welcome to do that as well. Yeah, you don't have to work with a partner, but there's that option to talk through some problems if you have any questions. Okay. Tuesday morning, I have a meeting at 7:45, but I will have a morning review going over that quiz review that you just picked up. If I don't have time to go over it on Monday, but Monday we need to finish up the rest of the package. Okay, you will get to use calculators, and the quiz will look like the quiz review front and back. Okay. Any questions? After this, we're going to be done with unit 2, and we're going to move it to unit 3. Okay, so don't forget your phones.
Over 1.5.
We could. We can move it back 0.5 or move this. For me, it feels more natural to move it to the right. But yeah, there are infinite ways that you can move it and still be correct. So I think that will work.
I do.